Hello. साहिल कोई आवाज मत लगाना किसी को भी। शिवा को भी आवाज मत लगाना, जाना तो प्यार से बुलाना। Hi, good evening everyone. I welcome you all in Let's Crack JEE in English. So we'll be studying today functions part 1, and I am your teacher Nishant Khanduja. So I'll be covering the definition of function, I'll be covering domain, codomain, range, classifications of function and types of functions today. So, but before that, let me introduce myself. I am Nishant Khanduja. I graduated and post-graduated from IIT Bombay in 2014, and post that I traded in US and Canadian markets for 2 years. But let me tell you guys, I have been teaching over the last 8 years. Now you might say, before graduation you started teaching? Yes, absolutely right. Because in my graduation days, I started teaching people, those who are preparing for JEE, NEET, and luckily somehow I was blessed with teaching, and finally I thought I should be sharing the knowledge which I have made during my preparation, the observation I made. And my rank was in IIT was 1256, AIEEE 363, and Rajasthan pre-engineering test, that is called RPET, all India rank was 4. Now you guys, just let me tell you a very, very interesting fact about me. You know, I didn't attend any coaching institute while preparing for IIT. Yes, absolutely right. So now you might ask, how did I prepare for it? So that's what I'm going to share with you guys. The way I prepared, the way I, did all the preparation, how I used to focus on basics, how I'm, used to make the observation. I used to use the observations while attempting the examination because that would increase my speed. So very, very small facts, very small basics I would be sharing, and I want all of you, whosoever is, just being there in village or tier 3 cities, tier 4 cities, just be there and relax and let me teach you guys. Let me share my experience with you guys, and trust me, guys, you all will crack IIT. If at all you will not be able to crack IIT, then believe me, you'll become a really good engineer or science student. Okay, so now this is the very basic reason why I joined Unacademy. So the reason being, because I know I couldn't go to quota, so that's why I didn't have those facilities how to prepare for a JEE competitive examination, being in a coaching institute. So how can I share my experience with others? So that's where this Unacademy comes, and they have a really good initiative, that is Crack IIT JEE, with India's largest learning platform, that is your Unacademy. So this Unacademy has got two sort of subscription. One is called Plus subscription, and the one is Iconic subscription. Now let's talk about the benefits. See, I'm teaching you guys here on YouTube. I know it's free of cost. It's a free platform. You guys just come and share your experience. You can ask your doubts. I'll be teaching you guys here. But what is the difference? What makes Unacademy Plus platform different from YouTube? So we'll be having daily live classes, and trust me guys, it's not me. You can have classes from the best teacher in India, be it physics, chemistry, anything you can study. Just be at home, be there in village, just relax, and whenever you feel like, you just study. And we have got structured courses. You don't need to just study multiple books. You just need to study what we teach. You just need to revise. Let's look like just look like bonsai. If you have that sort of aim, trust me guys, you will see good results. And we'll be having live test quizzes. You have unlimited access to recorded videos. Let's say if you miss my lecture today, it's okay, not an issue. You can access the video tomorrow as well, and you can revise it whenever you feel like. And what about the Iconic subscription? What makes it different? You get personal coach. And how does this personal coach creates the difference? It creates the difference when you are preparing for a competitive examination. He knows your strength, he knows your weakness. So he would tell you how to crack the examination, how to work on your strength, how to hide your shortcomings, because in the end, it's all about the marks you get in the examination. We have got study planner. He would tell you how you can study, because there are people, those they would like to study in the night, someone who would like to study early in the morning, and someone has some strong subjects. So they would plan in a manner that you get maximum marks. We'll be sending you test analysis reports, where exactly you're losing marks, where you need to work upon, because these are called critical statistic studies. These studies will help you to score better. And all the benefits, those are there in the plus. These are the 3 additional benefits you get here. Now let's talk about how can we get these experience, this plus experience and Iconic experience. What you need to do is, you just need to install Unacademy learning app. Once you install it, now you have got to buy a package, either for 6 months, 12 months, 24 months. Now I would suggest, trust me guys, this 24-month package is worth it, because that would cost you what, 2033 rupees per month, correct? And whereas if you just go for 6 months, that would cost you exactly the double. But when you have decided that you are going to study with me, you are going to study with a certain set of teachers, so why not? Why not go for 2 years? Because they would make sure that you perform really well. You don't need to change your teachers, because when we change teachers, it creates a lot of problem. So when you use that, okay, so when you go for 2 years package, that would cost you 56,000. But there's a gift from my end. You can use my code NK001, that would give you 10% off, and eventually the cost would become 50,400. But if some of you, those who are in 12th or maybe they have dropped, they can go for 1-year package. That would cost you, after applying my code, 34,650 rupees. Now when it comes to Iconic, again those 3 extra benefits are there, and now for 2 years the package would cost you 77,400 after applying my code NK001. Don't forget it, NK001. And when it comes to 12th or people those who have dropped out, they can use my code and the price would be 50,400 rupees. Okay, so let's start function. But before we start the function, I would tell you guys, just close your eyes and we'll be meditating for 5 minutes. Because see, in today's era, I know all of you, you guys are distracted. Some of you, play games, or some of you are having tensions. So let's do one thing. Let's get all the energy here in this class, and before starting the class, I would request you to just close your eyes for 5 minutes and just focus on your breathe. Inhale, exhale, inhale, exhale, inhale, exhale. Now I would give you count for inhale. So I'll be giving you 3 counts. So in these counts, I would request you to continue your inhaling. 1, 2, 3. And when I say 4, exhale in one go. 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now I would be changing it. When I say 1, inhale, and when I say 2, 3, 4, gradually exhale. 1, hold your breath. 2, 3, and 4. 1, 2, 3, 4. 1, hold your breath. 2, 3, 4. Now I would request you guys, just focus and just think. We are going to study functions. We are not getting distracted. There is no tension, there is no pressure from the parents, there is no competition. It's just we need to look after our own growth. That's it, nothing else matters here. We all are here to learn. That's it. Just keep breathing. Let the nervousness go away. Okay, now you guys can gradually open your eyes. Okay, so how are you feeling, guys? Feeling relaxed? Yes, that's the magic of meditation. Okay, so here we are starting with the definition of function. So what is that? Function is it's a certain rule that assigns to every element of set A, and it gives one and only one element of set B. Okay, so this is a very complicated definition, so I'll just make it easier for you. So this function is a rule which is applied to every element of A. So let's say set has got certain values, let's say maybe infinite or finite values. So this rule is applied to all these values, and for every value we get an image, we get an output. Okay, so that output belongs to set B. So how do we write that? We write, let's say f is such that it is defined from A to B. Here A is called your domain, and here B is called codomain. Okay, we also say, when I said every element of set A, so let's say for all x belongs to A, we have got y that belongs to B in such a manner, you can say such that f of x is equal to y. Now here this x is called independent variable and this is called dependent variable. So this independent variable can change its value on its own. And whenever this independent variable changes its value, you see there is a change in dependent variable. Got it? So far how we represent it and what is the definition of function. Now let me tell you guys one thing. This function can be seen like a mirror. Yes. So what does that mean? So what I meant is, let's say you have got a set A. Let's say 1, 2, 3, 4, 5. These are the values, or you can say these are the elements in set A, and there is another set B. Okay. Now just tell me one thing. When I put a mirror in front of this set A, so every element is standing exactly opposite to mirror. So what would happen? Yes, every element would have its own image, correct? And every element will have exactly one image, right? So what I mean to say is, when you'll see the function, it can be like this also. So every element has exactly one image, correct? So now this will be called a function. Now just imagine if you get this case. Here I got 1, 2, 3, 4, and let's say A, B, C, D, E. Now 2, 1, 4. Okay. Now let's say I have put a mirror here. Now can you please tell me, will you call it a function? No, you won't be calling it a function. Reason is very simple, because 3 doesn't have its image. When 3 doesn't have its image, that means this cannot be called a function. Clear? Now one more case I'll tell you. Now let's say 1, 2, 3, 4, and let's say A, B, C, D, E. Now let's say I have got this. Now tell me one thing. Will you be calling it a function? Tell me. No, you won't be calling it a function. Why? Reason is very simple. This 4 has got 2 images. See, when anything is standing exactly opposite to mirror, what happens? You would get only one image. You can't get 2 images of the same thing. Correct? So this is also not a function. So clear? The definition of function is, I guess, clear. And this particular thing is called mapping. People call it mapping. So I guess it's easier for you to understand the function of definition and how exactly you can imagine it. Okay? Perfect. Let's go ahead. Now let's talk about this domain, codomain, and range. But before that, okay, so I'll just tell you one thing. This set A is called domain, and this set is called codomain. This domain is what? This domain is the set of values of independent variable, or X, or I call it independent variable, where function is defined. Defined means function gives you a real value. So what I mean to say is, you should not get negative under square root. You should not get 0 in the denominator. So when all these things are there, we say that a function is defined. And what about codomain? But before defining the codomain, I would come to the range. This range is basically the set of all the images of function. All the images of function f. This is called range. Now what is this domain? Domain is basically the set of elements where range can be found, or you can say a set of all the images, or you can say a set of all the elements where images of the function can be found. So what I mean to say here is, I'll just go back and I'll show you here. So what I mean to say here is, let's say if I draw this mapping 1, 2, 3, 4, let's say 5, 6, 7, 8, 9, and let's say this is defined like this. This is the function. See, every element has got exactly one image, correct? Now as you can see, this 8 and 9, they don't have pre-image, or you can say 8 or 9 are not the images of any elements of set A, correct? but this entire part will be called the codomain, because all the images of this function f can be found here in this set B. And when I talk about range would be what? 5, 6 and 7. Simple. So codomain is what? Set of elements where images can be found. And one more thing, this range content equal to codomain. Range wala jo range set would be equal to codomain, and generally it would be always lesser than codomain. People call it range is consisted by codomain or consisted equal to codomain. Correct? Okay, now let's move ahead. Let's have one question, and this is exactly based on the basics. Now the question says find the domain and range of square root log base 3 cos sin x. Okay, so before finding the domain, let's go back to the definition of domain. What is the definition of domain here? Set of values of x, or you can say independent variable, where function is defined. Now see, when I say function is defined, what does that mean? That means this square root should have this inside thing. This inside thing should be what? Positive. When I say positive, so I can write it mathematically like this: cos of sin x, this should be greater or equal to 0. When I say it should be greater or equal to 0, so what does that mean? That means if I take, let's say, 3 as a base, so what would happen? So 3 exponential log 3, I'm just using basic log properties here, cos sin x greater or equal to 3 raised to 0. Now as you can see, this would become what? This would become 1, so eventually I'll get cos of sin x greater or equal to 1. Now tell me one thing, see, look at this result. This is very interesting result. Cos of sin x would be greater or equal to 1. Now tell me one thing, this cos, can it be more than 1? No, it can't be. So the only possible case here is cos of sin x would be equal to 1. So I'll just, this greater or equal to 1, this cannot be possible. Okay, explanation I have already given you. Now tell me one thing, this cos is 1. When does it happen? You can just, just recall the graph, whatever you have studied so far. It's very easy. Okay, so whenever we get integer multiple of 2 pi, we get what? We get cos as 1. So that means my sin x has to be an integer multiple of 2 pi. And here n belongs to, let's say, integer. Now again there's a catch. What is the catch? Look at the sin x values here. So sin x would be sometimes, let's say, 0, 2 pi, 4 pi, 6 pi, similarly minus 2 pi, minus 4 pi. Now tell me one thing, can sin x be 2 pi or 4 pi or minus 2 pi? No, it can't be, because again sin x also has a limitation that it can be between -1 to 1. Perfect. So that means the only possible case here is sin x can be equal to 0. When sin x is 0, this is the only possible case. When sin x is 0, that means my x can be what? It can be multiple of pi, integer multiple of pi. So x will be, let's say, integer multiple, let's say k pi, and here my k belongs to integers. Now just look at this magic here. When k is an integer multiple of pi, you will always get sin x as 0, then your cos will become 1, and your log 3 cos of sine x will be 1. Got it? So this domain is clear. So for these values of x, your function is always defined. Now when it comes to range, so range is what? Y is equal to, as we know, x will always belong to this interval, or you can say this sort of set, log of 3 cos of sine of k pi. So this log, this cos sine k pi, this k pi would become what? 0. Cos 0 will be what? 1. Log 3 1, it will be 0. So range would be 0. So range is done, your domain is done. That's it. Understood? Okay. So now since I have made you understand this first question, now I expect you guys to solve another question for me. And here is the second question. Okay. So in this question, you have to find the range of a function which is y is equal to x square plus 14x plus 9 upon x square plus 2x plus 3. Okay. Your time starts now. I'll be giving you guys, let's say, a minute. So you guys solve the question, and meanwhile I'll see what all people are saying. Okay. If you have any doubts, you can just leave a comment. I'll guide you how to solve this question. Come on, guys. If you have any doubt, you can just leave a comment. Okay, so just to give you an idea how exactly you can solve it, see, before finding the range, I would suggest you to find the domain, because once you figure out the domain, so for those values, you can check the range. Because if you don't know the domain, it would become very difficult for you to find the range. Okay, the time is over. Okay, let's see. So when you have to find the range, what exactly you need to do? Okay, so as I told you in the beginning, you have to first find the domain. So for finding the domain, what exactly you need to do here is you just need to check where exactly this function is defined. See, this numerator is defined for all the values of x. Very clear. We have to just, whenever we get this fraction, we always have to look after this denominator, because if this denominator becomes 0, this function would not be defined. Let's check where exactly this function would become, this denominator would become 0. X square plus 2x plus 3 is equal to 0. Let's check the values of x here. When I try to find the roots of this quadratic equation, I get imaginary roots. Now it's very easy. I'm just using the formula which has been taught to you guys in 10th, minus b plus minus square root b square, which is 4 minus 4ac, so 12 upon 2. See, this is minus 8. This is what? Root minus 8. That means imaginary root. So it clearly means that this quadratic thing will never become 0 for any real values of x. When that is the case, that means I can clearly say for all the values of x that belongs to real number, this x square plus 2x plus 3 will not be equal to 0. That means this function is defined for all the values of x that belongs to real number. Now let's figure out range. So whenever you need to find out the range, generally, so this is the method you see everywhere. What people do is they represent x in terms of y. So how can we do that? Okay, let's go ahead. y, I'll just cross multiply y x square plus twice of xy plus 3y is equal to x square plus 14x plus 9. Now further, this can be written as y minus 1 x square plus, I'll take x as common, so I'll get twice of y minus 14 plus 3y minus 9 is equal to 0. Now just look at this thing. This is a quadratic in x, and this quadratic has real solution. Why? How can I say that? Because see, this function is defined for all the values of x that belongs to R, correct? When this equation has real roots, that means my discriminant. Okay, so what is this discriminant? This discriminant is basically this b square minus 4ac. This is called discriminant. And what is this b and a? So generally standard equation, this quadratic equation is being represented by like this: ax square plus bx plus c. So now let's check here. What is b here? B is this, twice of y minus 14. So this would be what? 4y square plus 14 square is what? 196, correct? 2856 y minus 4 times a is what? Y minus 1, and what is c here? Thrice of y minus 9. This should be what? Greater or equal to 0 for real solution. Okay, till here everything is clear. Now let's solve this inequality. When we solve this inequality, what do I see? So 4y square plus 196 minus 56y minus, okay, 3y, okay, so this is minus 12y square. Then I've got minus 9y, okay, so this would become plus 36y, correct? Then minus 1, okay, minus 3y, this would become what? 12y. And 9 multiplied by minus 4, this would become minus 36. This is greater or equal to 0. When I simplify it further, what do I get? Minus 8y square, and this y minus 9, 36y, okay, this would become minus 20, minus 30y, okay, plus 12, okay, so minus 20y, 48 minus 8y, minus 8y, and 196 minus 36, this would be what? Plus 160 greater or equal to 0. Everything is clear here? Okay, I can take minus 8 common. When I take minus 8 common, I have to change the inequality sign. Whenever we take minus sign common or we multiply with minus 1, we always have to change the inequality. So this would become y square plus y minus 20 lesser equal to 0. I can factorize this, and this would become what? Y plus 5 into y minus 4 lesser equal to 0. Now how to solve this inequality? We'll just draw real number line, and I'll draw minus 5 here and 4. I've got 3 intervals. When I'll be checking for these intervals, so let's say if I put 5, what will I be getting? I'll be getting positive here, negative here, and positive. So for negative, because negative is required lesser equal, so this means this is the solution. So y would become, y will belong to minus 5 to 4 and close bracket, because this equal to 0 sign is here. Okay, so this is what? This is your range. That's it. Easy question. I hope you all understood. If anyone has doubt, you can ask me. I'm waiting. Okay, so since no one has asked the doubt, I'll move to next question. Find the range of f of x equal to square root 1 minus cos x, square root 1 minus cos x, square root 1 minus cos x, and it will continue till infinity. So infinite terms would be there in a similar fashion. Okay, again I give you guys 30 seconds. If you can just crack the question, you can just leave the answer here. I'll wait for you guys. And SYM24, good evening, good evening. Yes, you were late, it's okay, but you can still join us. And this is the question. As you can see, you have to find the range of f of x is equal to 1 minus cos x, square root 1 minus cos x, square root 1 minus cos x, and it will continue till infinite terms. Okay. So this question, okay. So when I saw this question, I could see, this question can be solved by two methods. So I'll be sharing every time. Okay, so let me tell you guys one thing. That's my personal experience, and that's how I used to prepare. See, every question can be solved in multiple ways. So when you're preparing for the examination, you better solve it multiple ways, because when you do it, you come to know which method is the shortest method, which method is the optimum method, because you have to save time and you have to figure out what are the hints here in the question that tell those methods, those ways tell you that you have to choose this particular method. You have to figure out the hint. That's what your observations are. So how I used to prepare is, I just used to, let's say in a week I have studied, let's say, quadratic equation. So whatever observations I'll make during this week, I'll just write them down on a piece of paper, and on the weekend I'll just read that piece of paper and I'll try to recall all those observations. That's how I used to, just increase my retention power. Because when you start retaining things, every question, whenever you are attempting questions in the entire syllabus, it becomes easier for you to crack the question. Because I have found many people, those people, they don't have good retention power, and in the end they end up spoiling question paper, and they have all the basic knowledge, but since they were not able to retain the basics, the observations, and they couldn't solve the paper in the given time of interval. Okay, so let's attempt this question. So in one way how I did it, this I told you in the previous question, I told you whenever you need to find the range, basically someone is asking you to find the value of y, correct? So let's say this f of x is what? This is y. So y is equal to square root 1 minus cos x, square root 1 minus cos x, and he'll keep going. 0.2 SYM24. Okay, I'll just check it. Okay, 0 and 2. Okay, cool. Let's check the range. 1 minus cos x. So SYM24, I would request you to just see which method you used to solve this question, and you can just save the second method for yourself, because here we are to explore the maths. We have to explore this maths. We need to see all the ways, all the possible ways, and infinity. Okay, so now just see, look at this. See, if we take out one thing from infinity, would it make any difference? No, it won't make any difference, correct? So I can rewrite this like this: y is equal to square root 1 minus cos x, and this remaining thing, doesn't it look like y only, right? It looks like function only, so I'll write it like y. Now I'll simplify it, I'll square it. Y square is equal to 1 minus cos x into y. Okay, now I can rewrite this as y, I'll take it as common, so y minus 1 minus cos x, and this would be equal to 0. Okay, now tell me one thing. It says y is equal to 0 or y is equal to 1 minus cos x. Okay, so let's say this is all, this is, let's consider this as true, because it can happen. When cos x will become 1, it would eventually become 0. Now let's take this case. As we know, this cos x keeps changing its value from -1 to 1, correct? So the minimum, the lowest value of y would become what? So 1 minus, because it's minus sign here, so we have to take the cos x maximum value here, 1. So when we are subtracting the maximum, we would get minimum for y. This would be what? 0. Now cos x can change its value from -1 to 1. Now I'll take the minimum value and I'll subtract it. When I'll subtract it, I'll be getting the maximum value of y. So 1 plus 1, it would be 2. So y minimum is 0 and it is 2. And in closed brackets. Correct? So yes, so range here would be 0 to 2, but in closed brackets. Yeah, sir, I use the same method. Okay, SYM. Okay, now let's SYM. This is for you. This is for you, guys. So now let's check the second method. Okay, so for second method, what I'll be doing here is just look at this. Y is what? 1 minus cos x. Okay, and this is, and again 1 minus cos x. 1 minus cos x. See, this thing has got, and it is going till infinity, and it has got power 1 by 2, whereas this until here, this has got power 1 by 2. So if I release this power, so I see that this becomes 1 minus cos x 1 by 2. When I release the power here, so I see it becomes 1 minus cos x 1 by 2 raised to 1 by 2. So that becomes what? 1 by 2 into 1 by 2. The other term becomes 1 by 4 into 1 by 2, right? Correct. So now just, and it will go till infinity, and this becomes what? 1 minus cos x 1 by 2 in 1 by 4. So this same number, same, your function is getting multiplied with different powers. What happens then? Your powers, they get added up, and they get added up. So 1 by 2 plus 1 by 4 plus 1 by 8 will go till infinity. Now what does it look like? This is a certain series. Yes, absolutely right. This is a GP. When this is a GP, so for GP, the summation of an infinite series is what? The formula, that is a upon 1 minus r. R is here common ratio. A is the first term. So I'll write it here, 1 minus cos x. A is what? The very first term is 1 by 2 upon 1 minus r. And common ratio is again half here. So I see what? I see 1 by 2 upon 1 by 2, it becomes 1. So I see y is nothing else, it is 1 minus cos x. Okay, so y is what? 1 minus cos x. Now cos x keeps changing its value from -1 to 1, and you can do the same thing what we did here, and you would get the same range. So y would belong to 0 to 2. That's it. So this is our second method. So yes, Adya, what you did, you use a different method. Oh, brilliant, brilliant. So Adya, absolutely right. Lovely, Adya, lovely. That's really good. You know, you use the second method. And SYM, I guess it is helpful for you. Adya, you must have seen how we did this question using the first method. So for both of you, you have got two different methods. And I hope, yes, it would be beneficial for you. Let's go to solve our next question. Okay, so in this question, we have to find the number of integers in the domain of the function satisfying this particular equation, f of x plus f of x inverse, or we can call it 1 upon x. I'll just simplify this for you guys. That will be equal to x cube plus 1 upon x. Okay, so again, I would give you guys 30 seconds and your time starts now. Okay, if you have any doubt, you can just leave a comment. I'll guide you how to go about it. Okay, so time is over, so let's see. Since none of you asked the doubt, so I hope yes you guys are attempting the question, and if at all meanwhile I'm just sharing the solution with you guys. If you get the solution, yes, you are free to drop a comment and leave your answer here. Okay, so in this what happened, f of x plus f of 1 upon x is equal to x cube plus 1 upon x. So whenever the function is not given to you clearly, so what exactly you need to do is you need to just play around. You need to use hit and trial so that you get more information about the function, or I can say more equation including the function. So here what exactly I can do, instead of putting x, I'll be putting independent variable as 1 upon x. When I do that, so at x is equal to 1 upon x, what do I see? I see 1 f of 1 upon x plus 1 upon x. So 1 upon this x, eventually this would come here. I'll write it here directly. I'll just leave it. This would be equal to what? This is x cube, so this would become 1 upon x cube plus 1 upon x. This can be further simplified as x cube plus 1, I have taken the LCM, and x square. Okay, now just look at this. This is, let's say if I consider this as equation 1, and this can be called as equation 2. See, both of them are the left hand side for both the equations. These are the same, correct? And both left hand sides are same. I can equate it, because see what happens in the questions is we have to use the given information because no other information is being provided, and based on the given information we solve the question. So this is the given information here. So now we'll be using it. So when I'll be equating equation equation 1 and equation 2, so what do I see? I see x cube plus 1 upon x is equal to x cube plus 1 upon x square. Okay, now I'll be taking everything to the left hand side, and I can take x cube plus 1 upon x as common, and what do I get? I get 1 minus 1 upon x is equal to 0. Okay, now let's see what all options are possible. One is 1 minus 1x will be equal to 0, or x cube plus 1 will be equal to 0. When I solve this, what do I get? I get x will be equal to 1. From here I get x cube is equal to minus 1. Then I can clearly say x will be what? Minus 1. Okay, see, if you will solve this cubic equation, you will be getting 3 roots. So I would tell you, see, I can tell you guys, yes, when you will be solving it, you will be getting this quadratic expression also. When you get this quadratic expression, okay, I'll just made a mistake. It will be x square minus x plus 1 is equal to 0. When you'll be solving it, you will be getting what? Imaginary roots. So I'm just not considering not writing them here, but yes, you can certainly. But the question says we have to find the number of integers in the domain. So as you can see, the domain has got this x is equal to 1 here and x is equal to minus 1 here. So we have got 2 integers in the domain. One is 1, another one is minus 1. So the number of integers in the domain would be 2. So 2 is the correct answer. And if you feel like, you can just check your answer, cross check. You can just put f of 1 plus f of 1 upon 1, and you see 1 plus 1 upon 1, so twice. So f of 1 is your 1. Similarly, you can check for minus 1 as well. Okay, so I hope you got the question. And yes, Swam Prakash Malik, yes, I have not written it because it's about the integer. So I just told you guys you'll be getting imaginary roots, so that's why I didn't write them, but I have told you guys. Okay, so Adya says plus minus 1. That's really good, Adya. That's really good. You got the right answer. And so 2 answers, absolutely right. That's really good, guys. You are cracking almost every question. I hope you enjoy. I'm just feeling grateful that yes, whatever I'm teaching you guys, you could understand it. Cool. Let's move ahead. Okay, there is one more question. So this question says we have to find this function's maximum value. Okay, so the function is given to you, f of x is equal to square root 4 minus x square plus square root x square minus 1, and then we have to find the maximum value of f of x whole square. Okay, and again I give you guys the same time. Okay, this time I'll just increase the time a bit. I'll make it 45 seconds. The time starts now. Anyone has doubts? Yes, you can leave a comment and I'll help you guys out. Okay, SYM, you got only one in the last question. I hope you must have seen your mistake, and if you have any doubt about your mistake, yes, you can leave a comment. I'll clarify your doubt. Okay, good. Yes, still we have a few more seconds. Okay. Okay, chalo. Let's crack this question now. Let's crack it. Okay, so function says f of x is equal to this. So we have to find the maximum value of square of f of x. So first find the square of f of x. So we see that 4 minus x square, someone has written the answer. Other says, do we have to tell the maximum range? No. Okay, I guess other you meant you have to tell the maximum value of range. Yes, absolutely right. So I'm says it's 3. Okay, so let's check this out, because even I don't know. I'll be solving it in front of you, and I hope I'll be solving it correct. So okay, so when I'm squaring it, so I'll get 4 minus x square plus x square minus 1 plus twice of square root 4 minus x square minus 1. So Adya, I'll just clarify this for you, that you have to find the maximum value of this. Okay, so this can be, so x square will be cancelled out, so I'll get 3 plus twice of, okay, so 4x square, and then I'll have minus 4, I'll have minus x raised to 4, I will get x square. So eventually I'll be getting twice square root minus x raised to 4 plus 5x square minus 4. Okay, other says root 3 and root 6, you guess. Okay, we'll check it. Wait for a minute. Okay. So this, okay, so minus x raised to 4 plus 5x square minus 4. Okay, I hope you guys have studied a quadratic equation. So see here, this is a quadratic expression in what? X square. Now, and as you can see, the coefficient of x raised to 4 is what? Negative. That means the quadratic, if I draw, that would be what? Concave downward. So that means I have to take this vertex value. Once I get this vertex value, things would be easier for me. Correct? So let's find the maximum value of this vertex. So this maximum value of this vertex is what? Minus d upon 4a. If let's say you guys don't know it, it's okay. Let's forget about it. You can directly use this formula to find the maximum value. If you don't remember it, it's okay. So what we'll be doing is, let's say we'll be substituting x square as t. So this becomes minus t square plus 5t minus 4. And if I solve this, if I try to factorize this, what do I get? Minus t square plus 4t plus t minus 4. This becomes what? Minus t as common. So minus t. So I get t minus 4, and from here I get plus 1. So as you can clearly see, the range, so t is equal to 1 and this 4. These are the roots of this quadratic. Now exactly at between, so between would be what? This point would be what? 5 by 2. So at 5 by 2, when t is equal to 5 by 2, you will be getting maximum value, correct? So you can just directly put t as 5 by 2 to get the maximum value. So this is the basically vertex. When you'll be putting t here, so this t as 5 by 2, so what do you see here? So I'll be getting the maximum value as, when I put t as 5 by 2, at t 5 by 2, I'll be getting it minus 25 by 4 plus 25 by 2 minus 4, and when I solve it, what do I get? 4. So minus 25 plus, so this would become 50 minus 16. So I get this 25 minus 16, 9. So 9 by 4. So this is the maximum value which is there in the square root. So max of f of x whole square would be what? Thrice plus twice of 9 by 4. So this would be thrice plus 2. Square root of this would be what? 3 by 2. So 2 will cancel out. So eventually we'll get 6. So 6 is the right answer. So this is the maximum value of f of x whole square. Okay, so Swam Prakash Malik, you got the right answer, 6. Okay, it's okay. So I hope you got your mistake in this question, where exactly you went wrong. And what about Adya? Adya says root 3 or root 6. I hope you got your mistake as well. If you have any doubt regarding your solution or regarding my solution also, you can just leave a comment. I'll explain it to you. Okay, let's move ahead and let's see our next thing. Okay, so now we'll be studying this classification of functions. So generally this topic, generally people don't cover it much because they find this is not a part of this. So this is a part of a syllabus, but they don't cover it on a large basis. But I find this is a very good thing because everyone should know the basic, because sometimes what happens, I have found people, they are not being able to prove whether a function is many one, into or onto. So that's why I thought before starting the type of functions, I will be teaching this classifications of functions. Okay. So what is this many one? So many one is basically your different elements of set A, or I can say different elements of domain. They have got the same image. So what I mean to say mathematically, if I want to write, so what I mean to say is, let's say x1 and x2, they belong to domain. So domain has got, let's say, 2 elements, and both are not equal, they are different, but they are related in such a manner that f of x is equal to f of x2. Their images are same. When it happens, then we call a function is many one. Or if you want to see in a mapping, just to imagine it better, see, let's say a, b, c, and I've got this function, let's say 1, 2. So as you can see, a and b both are different, but both are having the same image, 1. So this will be called a many one function. Or you can say that different elements, they are coinciding exactly at one point. They're having exactly one image. Here, this is many one. Now what is 1, 1? So in 1, 1, the meaning is every element has got different image, or you can say unique image. So what I mean to say in mapping 1, 2, 3, and let's say a, b, c, d. So 3 is related to d, this 2, and 1 is related to b. So as you can see 1, 2, 3, all 3 of them, they have got different images. Those images are not equal to each other. So this will be called 1, 1. And when it comes to how to prove this in a mathematical form, because sometimes we get this sort of question, so I'll explain that to you in the next slide. And let's first clarify all the definitions. So I hope 1, 1 is clear to you. So now let's go to this into. So into is basically what? Here we focus on codomain. So this is our A, this was B, and let's focus on codomain here. So 1, 2, 3, let's say A, B, C, D. So let's say 1 is related to A, B, 2 is related to C, 3 is related to B. Now in this into function, what happens? Every element, there is no necessity, there is no compulsion, there is no necessity that every element of B will have its preimage. As you can clearly see here, D doesn't have preimage. Then it will be called into function. Whereas in onto, every element of codomain will have to have its preimage. So let's say this. See, every element has its preimage. Clear? So this will be called an onto function. Correct? Okay. Now I would also make you understand what is the graphical interpretation of many-one, one-one, onto, and into function, because that's very important. Because once this classification of function is over, I'll be teaching you guys different methods to prove whether a function is one-one, many-one, into, onto. Sometimes this, instead of using mathematical approach, this graphical approach becomes very easy. It saves time. So okay, so let's start with many-one. Let's see its graphical interpretation. So as you know, what is the definition of many-one? Many-one is one y, or you can say one element of B, or one element of codomain has more than one preimages, correct? So, or in other words, I can say one value of y has more value of x. So let's say if I draw the function like this. So to check whether a function is one-one or not, what I'm going to do is I'll be drawing a parallel line to x-axis, and I'll be checking how many times it cuts the function. As you can see, this is cutting the function here at 3 points. So for this value of y, I have got corresponding 1, 2, and 3 values of x. So in other way, I can say, so for let's say x1, x2, and x3, I'll be getting the same y. So for these 3 different x, my image is same. That means it's a many-one function. So for many-one function, very easy. What you need to do is you need to just draw a parallel line to the x-axis and see how many times it is cutting the x-axis. If it cuts the x-axis more than once, that means the function is many-one. Now one more tip I can give you: whenever function is not monotonous. Now what does that mean, monotonous? Either increasing or decreasing. If function is not either increasing or decreasing, it would be cutting the graph more than once. If a function is monotonous, it will be for sure one-one. If it is not, it will be many-one. Correct? So if the function is cutting, if the horizontal line is cutting this graph only once, then the function will be called one-one, as you can see here. So this is one-one's example, and this is your many-one example. Okay, cool. Now let's talk about into and onto. See, into and onto are based on codomain. I told you in the beginning. So we have to focus on codomain because we have to check whether codomain's elements, are they having pre-images or not. If all are having the pre-images, that means it's onto. If not, they are into. So let's do one thing. Here I'll take a graph and I'll keep codomain and domain as real numbers. Now let's say I draw this curve, and let's say I draw another question, I draw this curve. And in both the cases, my range, my codomain and domain, both are real numbers. Now check this function. This case, in this case, as you can see this y-axis, this represents what? Codomain. Now, as you can see, for negative value of y, we have not got any pre-image, correct? When we don't have pre-image for negative values of y, what does that mean? That means this function will be 2. Whereas here, as you can clearly see, every single value of y, every single value of codomain has got some, this has got some pre-image, correct? When every value of x has got pre-image, this value has got pre-image, this value has got pre-image, so in that case this will be an onto function. I hope everything is clear to you guys. If you have any doubt, you can just leave a comment, I'll help you out. Okay, so sir, I did not get where exactly I went wrong in the previous question. Okay, so if exactly you have seen my solution, if you have any doubt, you can just consult to the solution. You can just go back and see the solution in the video itself. Okay, so I hope everything is clear. Now the part comes how to identify whether a function is 1 1, many one, or onto, into. So one is mapping. If let's say set is given to you, then it becomes very easy. So set with a certain values, or I can say finite values. If that is given to you, then you can use mapping, and that's very easy approach, and you can just get the answer. Graphically again, it's easy. What you need to do is, I'll show you, I'll tell you maybe tomorrow, I'll tell you how to draw the graph of a function. When you can draw the graph, when you see the graph, and you can just simplify, draw its domain and codomain, and in that codomain and domain you can see whether a function is monotonous or not. If it is monotonous, then it is 1 1, and if it is covering all the values of codomain, that means it's onto. If it is not covering all the values of codomain, that it is onto. Here now comes the mathematical part. That is not tricky part, because sometimes what happens, we are not able to draw every single functions graph. We can only draw functions graph, those are very close to standard function, and the method we study, if we can draw the graphs based on those methods, we can draw them. If not, then we have to use this mathematical approach. So again, I have to judge which one is simpler, which one is difficult for a particular question. And that's what I want you guys to have. I want to inculcate this sort of knowledge in you. You have to determine, you have to be analytical enough to choose the right method. Okay, so in mathematical approach, what exactly we do? So first we'll check for many one and 1 1. Okay, many one and 1 1. So what exactly we do is, we assume that function is many one. If we find our assumption is true, then we say yes, our assumption was right and it will be many one. If our assumption turns out to be wrong, then we say okay, it's fine, it's 1 1. So let's assume x1 and x2 both are different number and both belong to your domain. Got it? And such that f of x1 is equal to f of x. Okay, now we start simplifying it, and if at all, if we get x1 is equal to x2, then we say it's 1 1. Now why do we say it's 1 1? It's very simple. See, we assume that both are different, these two numbers are different number, but they turn out to be same. So what I mean to say is, if you just want to see in mapping, see, we assume these two are different and they are having one image, okay, same image, but they turn out to be equal. Actually they turn out to be the same. That means there is only from one element there is exactly one line, correct? So then it will be 1 1. If not, if we get this only, then we stick to our assumption, then it's many one. If you want to see an example, okay, I'll give you an example. Let's take, best example would be, let's say, linear function. So for linear, let's say f of x is equal to 8x plus 10. Okay, and here f is defined from real to real. Now we'll assume that, let's say, x1 and x2 both belong to real number and both are different, but such that f of x1 is equal to f of x2. And when you do that, what do you see? 8x1 plus 10 is equal to 8x2 plus 10, and finally it turned out to be x1 is equal to x2, because 10 will cancel out, 8 is common, that can be cancelled out. Eventually you get x1 is equal to x2. That means what? That means this function is 1. Simple. Okay, now let's go for into and onto check. So for into and onto check, what do we do? We say, let's say function is defined from, again, let's say from set A to set B, and such that f of x is equal to y. Now we try to represent x in terms of y, or you can say x will be returned in terms of y. Okay, when we write that, now just see, now what do we do is, because see, this is a codomain, and for into and onto, the main player is codomain. So for all the values of y that belongs to B, we check whether we get x, or whether we get preimage for all the values of y. If we get for all the values of y, if we get preimages, then what? It will be called onto. If we don't, then it will be into. Simple, right? And if you want to check, okay, so let's say I can check for this also, your linear function. So let's say okay, no, let's not take, because linear is very easy. Let's take quadratic. For say quadratic, that would be a better option. So f of x is equal to, let's say, x square plus 5x plus 6, and let's say this is y is equal to x square plus 5x plus 6. Now I can rewrite this as x square plus 5x plus 6 minus y is equal to 0. Now what I'll be doing here is, because as I know that your x belongs to real number, correct? So x has real roots. This equation has real roots. So for that, what should happen? Your discriminant, which I told you earlier as well, that discriminant would be greater or equal to 0. Correct? Let's do that. When you do that, what do you see here? You see here that your b square is your 25 minus 4ac. So this 6 minus y greater or equal to 0. So from here, I'm just crossing it, I'm just marking it so that yes, you can cross check it. So 25 minus 24 and plus 4y greater or equal to 0. Then it would be 4y greater or equal to, and this is 1 minus 1. So as you can see, y will be what? Greater or equal to minus 1 by 4. So y will always be more than minus 1 by 4. Whereas I have given you codomain what? Real number. But this range says, dude, I will be always more than minus 1 by 4. So if you see it here, see your y, your codomain is this real number, the complete y-axis. But your function says, dude, I'll always be more than minus 1 by 4. So these values which are just below minus 1 by 4, they are not having any preimage. When it is the case, then I can clearly say that it is going to be into function. This will be what? And into function. Got it? Got it? So I hope yes, you must have understood. So how exactly we can use mathematical approach, and you should know, because sometimes I'm telling you guys it would be very difficult for you guys to use graphical method. Then you can just use them and find the answer, because as I told you earlier also, the previous question, when you guys just solving this question, let's say uh, this question, when we were having this rational function, for rational function drawing the graph is very difficult, but when you are solving the range thing, you can easily find out whether this function is into or onto. Okay, let's move ahead. Okay, we have got question. Okay, so check whether the function defined from R to R, real to real number, such that f of x is equal to, I'll just correct this, f of x is equal to exponential x minus e raised to minus x by 2, whether it is 1 1 and onto. Okay, now your time starts now. You can just use the approach which I used. You have got a minute, because this is a bit longer question. You can choose whichever approach you feel like. Again, I can solve this question using 2 approaches. I'll show you, don't worry about it, but I'm open for any solution, so go ahead. Okay, SYM dude, I hope you'll be able to crack this question. Swam Prakash Malik, I'm just waiting for you. Come on, Adya, you can also solve the question. Okay, any doubts you have, you can just leave the comment. I'll guide you whatever doubts you're having while solving this question, or maybe whatever I taught you lately regarding classification of functions, anything. You can just drop a comment. Okay, let's say time is over. Okay, so let's again, I would say let's use both the approaches, graphically and mathematical, because again we have enough time and we are here to study and explore. We should know how to solve the question and by which method. Okay, so by every method we'll be solving the question. First we'll start with let's say mathematical, because lately we studied this only. Mathematical approach. So for 1 1, what I told you, we assume as if it's a minimum thing. So I'll assume that x1 and x2 both are different. For all x1 and x2, they belong to a real number, such that your f of x1 is equal to f of 2. So I'll be rewriting this, and this would be e raised to x1 minus e raised to minus x1 by 2 is equal to e raised to x2 minus e raised to minus x2 by 2. 2 will cancel out. I'll be taking the LCM as well, and it would become e raised to twice of x1 minus 1 is equal to upon e raised to x1, e raised to twice of x2 minus 1 upon e raised to x2 here. Okay, now let's cross multiply. When we cross multiply, what do I see here? I see here that it would become e raised to twice of x1 plus x2, because when we have same base and then power, they get added up. Minus e raised to x2 is equal to e raised to twice of x2 plus x1 minus e raised to x1. Okay. Now we can just take everything to the left hand side and take common things. So I can take e raised to x1 plus x2 common, and it becomes what? E raised to, so see, I'm taking common from this and this term, so I get e raised to x1 and minus e raised to x2, and when I'll be taking this term, so it will become positive, so e raised to x1 minus e raised to x2 will be equal to 0. So when I'll be taking this e raised to x1 minus e raised to x2 common, and I get e raised to x1 plus x2 plus 1 is equal to 0. Now see, there is very good thing here. Either this will be 0 or this term will be 0. Now tell me one thing. This second term, will it be 0? Tell me. Again, you have 10 seconds to answer. I'm just waiting for the answer. Come on. Say it. Can it be 0? Think. Come on, Swam Prakash Malik and this SYM24 are there also. Can it be 0? Come on, guys. Any, come on. Yes, no, yes, no. You can just write Y or N. Come on. Okay. Okay. Unluckily, I didn't get any answer from you guys. Okay. So let me tell you guys that this e raised to x1 plus x2 plus 1, it can't be equal to 0. Reason is very simple, that see, this is 1 is positive number, and this thing e raised to x1 plus x2, this is what? This is an exponential thing, and this is always more than 0. So positive number plus positive cannot be 0. So this can't be 0. So this cannot be equal to 0. This can't be equal to 0. The only possible case here is this, e raised to x1 minus e raised to x2 will be equal to 0. So that says x1 will be equal to x2. Okay, so we got this. When we got this, what does that mean? Whatever we assumed that this was our assumption. Assume this, but it turned out to be both are equal. That means this function is what? 1 1. So there is tick mark on 1 1. Yes, it's 1 1. Okay. Now let's talk about onto. So for onto, what we'll be doing is, if you remember, I told you guys, we'll be writing y as e raised to x minus e raised to minus x by 2, and we'll be writing x. I told you guys that we'll be trying to find x in terms of y, and we'll try to get the answer. So now I'll be taking the LCM. It would become what? Twice of y e raised to x. I have taken the LCM and I have cross multiplied also. So e raised to 2x minus 1, and this is e raised to 2x minus twice of y into e raised to x minus y is equal to 0. Now as you can see, this is a quadratic equation in exponential x, e raised to x, correct? This exponential, as I know that for every value of x, because this function is defined from r to r, so for every value of x we are getting some images, correct? Now this equation has real roots, true. So now when we are getting real roots, what does that mean? That your discriminant should be greater or equal to 0. It should be greater or equal to 0. That means p square minus 4ac should be greater or equal to 0. And what do I see? So I see y square plus 1 greater or equal to 0. Now tell me one thing, guys. This y square plus 1 is greater or equal to 0. Don't you think this is true for every value of y that belongs to a real number? For all the values of y that belongs to real number, it holds true, right? It's positive plus positive, it will always be greater than 0, correct? So for every value of y, we are getting the pre-image, correct? But as you can see, because it clearly says for it holds, this inequality holds true for every value of y. That means for every value of y, we are getting the pre-image. So that means this function is onto as well. Sorted? So this is our mathematical approach. Now see, this must have taken what? Around 3 minutes, because I was explaining you. But let's see the graphical approach. That would make this question very easy. I'll show you guys. Okay. So first, this is what? E raised to x minus e raised to minus x by 2. Oh, I hope you know the exponential graph. E raised to x graph is like this. And for e raised to minus x, the graph is like this. Now see, when I say 1 1, okay, so what is happening here is you are subtracting from exponential x this thing, correct? When you're subtracting it, so eventually what sort of curve you'll get? I will be drawing the resultant curve here. From e raised to x, you have subtracted e raised to minus x. Okay. So what would happen is, as you can clearly see, this e raised to minus x is more for negative values of x, correct? Is going towards minus infinity. Okay. So when you are subtracting from a small number which is very close to 0, you are subtracting the bigger number. So you will get almost negative bigger number. So it would be, let's say here like this. But when you go to x is equal to 0, what happens? 0, 1, 1 minus 1, 0. So basically it would pass from 0. For x which is greater than 0, you are subtracting very small number from a bigger number. E raised to x में से क्या subtract हो रहा है? Minus e raised to minus x. When you are subtracting that, what do you get? You get bigger number. Correct? So this sort of curve you'll get. And by 2, what will happen? By 2, it will just, your curve for every values of x, your curve vertically your curve will just shrink. That's it. Nothing else. So this is your y and this is your x. Okay. So now see one thing. Graphically, I told you, for 1 what do? We just draw the horizontal lines. And as you can see, when we are drawing the horizontal lines, this horizontal line is cutting the graph only at one point, or only once. That means this is 1, 1. And as you can see, it is covering all the values of y, all the values of codomain. From minus infinity to infinity it is going. That means it is onto as well. Sorted. The question was solved within a minute. You just need to know the graph. That's it. I hope you like both the approaches and you have seen what is the benefit of different approaches. Okay, let's go to our next question. Okay, so the question says there is a function which is defined from natural number to natural number, where f of x is what? X minus 1 raised to x. Then we have to comment on function, whether it is going to be 1 1 onto many 1 into many 1 onto and 1 1 and into. You can use the same approach, which is completely fine with me, and solve the question. I am open for both the approaches, whether it could be graphical or this your mathematical approach. I'm open for both the approaches, and you can just answer whether it is A, B, C and D. Come on Adya, come on this Swam Prakash. Guys, okay, I'll give you 15 more seconds. Just think what exactly you can do. Think about this question. Okay, now I'll just help you out. Okay, so let's okay, Adya says 1 second. Okay, Adya, I give you more time. Okay, A, 1 1 and on 2. Okay, good, Adya. Option A. Okay, fine. Let's check what does whether Adya has got the right answer or not. Okay, so function. Okay, so here f of x is equal to x minus this minus 1 raised to x. So in natural numbers we get two options. One is odd and another one is even. So let's see. The function would be x plus 1 when x is what? Odd or even? See, when we'll be getting odd, we'll get minus 1 only. So minus 1 minus this minus will become plus. Odd. If x is your even, you'll get this as plus 1, x minus 1. Okay. Now see the magic here. Now just check. For odd, when I put odd input, what do I get? The image. When the input is odd, what am I getting? For odd, I am getting the even, because we are adding one number. We'll get even, and we get more than that. Okay, but the input is even, we get odd because we are subtracting 1, so we get odd, and we get the lesser one. Just, you can take any natural number. Let's say if you take 2 is what? Even, so you'll get 1. If you take let's say 3, it is odd, you get 4. Cool. So as you can clearly see, this will be covering all the numbers here, all the natural numbers. So this will be for sure onto here. And when it comes to 1 1, so what you can do is, as you can clearly see, that what you can do is, let's say take two different again, you can take two different, let's say odd numbers, and x1 and x2 both are different odds. When you take different odds, so x1 such that f of x1 is equal to f of x2, you get what? x1 minus 1 is equal to x2, or x1 plus 1 is equal to x2 plus 1, and which tells you x1 is equal to x2. Basically, but different odds you were assuming both are same. Same goes for even as well. For even also, you'll get x1 is equal to x2. So this says it is clearly 1 1 function. Clear? Using your mathematical approach, it's pretty clear to you guys. Okay. Now, if you want to solve it using your graphical method, then what you can do? Simple. See here. You can just take numbers and see, it seems like a straight line, but since it's a natural number, so you will be drawing the graph, or you will be just representing the dots at integers. So for 1 you will be getting what? 2. Here for 2 you'll be getting 1. For 3 you'll be going up, so you'll be getting 4. For 4 you'll be getting 3. As you can see, it's like this sort of graph. You'll be, sorry, I'm really sorry, I'll just clear it out. Okay, I just joined them, and that's my mistake. We erase it. The options screen. Wait a minute, guys. Okay, yes, I've got eraser. Okay. Yes. Okay, so as you can see, for every integer, you'll be getting this sort of thing, like this. Okay, so for 5 you'll get 6, and for 5 you'll get for the 6 you'll get 5, like this. So as you can see, so every element of codomain is being covered, and for each input we are getting exactly one output. So that clearly says we are getting 1 1 and onto function. Correct? Sorted. So both ways you can solve the question. I guess both ways you'll be getting the same answer, and I prefer here, I would prefer a graphical approach, because that gives me visualization of the function, because that is also important. That that makes you sure that yes, you are marking the right answer. Okay, let's move ahead. Oh, okay, the class is over for you guys. Okay, I am really thankful that yes, you were very patient enough, and you spent almost 90 minutes here for this class. Tomorrow we'll be studying about types of function, but before that, as I have told you, in today's generation, this concentration, retaining things, that has become a problem. So I would request you guys to just close your eyes for 5 more minutes and just think about what we studied today. Just think. Okay, so we started with the definition of the function, and it can be represented like a mirror. We used mapping, then we mapping. Okay, so we took the different examples. Then using the mapping only, you can directly approach this classification of functions: one, many one. Then you have got into, onto. Just recall everything. And we also spoke about a definition of codomain, domain, range. What is the difference between range and codomain? Range is always considered equal to codomain. Okay, range is a smaller set, codomain is a bigger set, and all the elements of range can be found in codomain. And when range becomes equal to codomain, then the function is what? Onto. Correct. So you can just recall these things. Just recall them. Just breathe in and breathe out. Just recall everything. And you can just open your eyes, and you can just leave your comments. I'll be reading the comments most probably late night, so I can just write down. I'll try to resolve your queries in the next class. And what you can do is, if you like my class and if you want to be updated about the class, you can just subscribe the channel, and you can just hit the bell icon. You can like the class if you like my teaching style, and if you want to have greater experience, because this weekend, this Sunday, I'll be taking a class on functions. I'll be covering the basics, the observations, or people call them tricks, but I don't call them tricks. It's the observation which we made while studying, plus JEE questions. So when we'll be solving JEE questions based on functions, we'll come to know, so whatever we studied, whether we can crack JEE questions or not. When we solve those questions, when we'll be able to solve those questions, it would boost our confidence. Yes, we are made for this competitive examination. And when you're going for Unacademy, yes, do subscribe this either plus or iconic. If you want to have personal consultancy, personal guide for you, then certainly buy iconic and use my code, that is NK001. I'll state it once again, NK001, and you can just have me for another 2 years, and I'll be guiding you forever. Okay, see you guys. I'll be seeing you tomorrow 8 p.m. and those who want to have class in Hindi, they can join me tomorrow morning 6 a.m. Okay, so we'll be having part 2. Okay, good night guys. Bye bye. Take care.